All right, so we have the vertical motion model, which is an introductory here, and this is going to be Algebra 1 class, where you see something, when you see like this number 11 here, the way you read that is h of t is equal to negative 4.9 t squared, okay, plus, say, 6t plus 12. And I'm going to make a different problem here just to illustrate. Okay, and it's asking how many seconds does it take to hit the ground and around a certain value. So we're going to do this with a different problem. So I don't want to do your homework for you, but how long does it take to hit the ground? So just a quick explanation about what some of these are. This negative 4.9 is actually half of acceleration due to gravity in meters. Okay, so you'll see sometimes a negative 4.9, sometimes a negative 16. If you've taken science class, physics, acceleration due to gravity is negative 9.81 meters per second squared or negative 32 feet per second squared. There's a reason that's half. It comes from calculus. I'd love to be able to show you, but that's going to be for later. This is the initial velocity. So how much something is, how quickly it's thrown or ejected. And this is the initial height, how far above the ground it is. But for this course, you don't really even have to know what all that stands for. What we know is when it hits the ground. So h of t represents the height at any given time, at time t. So it's going to hit the ground at height 0. That's the ground level here. So I'm going to make this a 0. And basically, this is just a quadratic formula problem. You definitely don't want to try to factor that. It has a decimal in it. You'd have to multiply by 10, get rid of the decimal, and then there's a good chance it won't factor anyway. So we want to avoid trying to factor. We're just going to go straight in the quadratic formula. And remember, the quadratic formula will always work. It's not always the easiest, but it always works. Don't declare your variables until you have a 0, which we already do. So we know a is going to be negative 4.9, or the coefficient of the squared term. B is 8, which is the coefficient of the t, the linear term, t to the first power. And c is your constant, which is just your number. And we're going to load all this into the quadratic formula. Now remember, it's probably a good idea to put this in parentheses. Here it's not going to matter because you have a positive b, but that would cause trouble if there's a negative b. So always remember that in the quadratic formula. All right, so let's make sure we got everything in there correctly. This should be negative b, so since b was 8, it's negative 8. This should be b squared, so 8 squared, parentheses is a good idea. 4ac, there's a, there's c, so I'll put them here and here. Then on bottom 2a. Okay, this one's going to require a calculator. You've got decimal in there, so most of the time you use a calculator anyway. All right, so I'm just going to, matter of fact, I'm going to demonstrate on Desmos how to just do this all at once. All right, so let's go there. Let's go to Desmos. So it's negative 8 plus or minus. Now it's not going to let you do plus or minus. Matter of fact, I'm going to put the whole thing in parentheses so I can put it all on top. So negative 8 plus square root. I like to say SQRT to make the square root come up. I'm going to put 8 in parentheses. Those, again, it's not really necessary when it's a positive b. Minus 4 times 4.9. So negative 4.9. Like Desmos, once you start a parenthesis, it will remind you that you need to finish that parenthesis. So you can kind of see this little gray parenthesis here. And I just did something and it went away. I'm not sure what I did. Let me undo. There we go. I want to divide that. I would like to have, all right, so anticipate having an issue here with decimals. There we go. So divided by 2 times negative 4.9. That did cause a little bit of an issue. I remember we're looking for when it hits the ground. This doesn't make sense. It's a negative number. You might think, well, something's wrong. Well, no, remember right here, that's a plus or minus. Okay, so going back, look at our board. I did the plus because the calculator's not going to do them both for it at the same time. So I'm going to go back and just fix this to a minus, and that should fix the negative problem we have. We'll change this to a minus. And indeed it did. So x is 2.7. I can't remember where it said to round. I'll just go 2 decimal places. So it's going to take 2.75 seconds for that to hit the ground. Okay, and really, when you have a question that asks when it hits the ground, you just put a 0 where h is and you use the quadratic formula. And you're going to need technology anyway with the decimals. Just remember that you might have to do a plus or a minus right there. So let's see what else they ask us on this sheet. Number 12 is, again, it hits the ground. 13 says a quarterback throws a football 6 feet above the ground at a release velocity. Okay. If the pass fell incomplete, how long would it take for it to hit the ground? So just asking again, same deal. How long does it take to hit the ground? I do want to point out on this one that's got the negative 16 because it changed from meters to feet. And that's all that is. Let's look at number 14 here. It gives you the equation and asks, what is the height after a given number of seconds? So I want to do a problem similar to that. We'll make one up here. This one has feet. So let me make up something similar to this. H of t is equal to, okay, we'll go feet also. I'm going to change some of these numbers so you can do your problem. So the question is, when is it after 2 seconds, how high is it off the ground? Well, what you would do here is just put a 2 in for t. Okay, remember, h is height at any given time, t is your time. So I'm going to put a 2 here, and I'm going to load these up with 2's. Again, not that important to know right now. This has something to do with gravity. This is your initial velocity, your initial height, but you can survive this year without knowing that. I'm going to do the order of operations here, though. You could just go right into decimals and do all this. 2 squared is 4. Remember, you should do the exponent before you multiply. Negative 16 times 4 is negative 64. 60 times 4 is 120. If you add all this up, again, you're going to probably need decimals anyway. Right now, our calculator, this will be 56 plus 8, I believe, is 64. Okay, so then we're in feet for this one. So just put your units. So if you want to know the height at a certain value of time, you just put that value of time in for t. So no quadratic formula here is needed. You're just evaluating. So that's the difference. Remember before when it says hit the ground, you change this whole thing, the whole height to 0, which makes it harder because you have a t that's being squared there. Let's see how much time we have, if I can. I have less than a minute. So we'll just leave it with those 2. So hit the ground, make sure that you set it equal to 0, the whole thing. If it says at a certain time, though, you want to replace that t with that time.